Hi, my name is David Follis, and I'm a member of the WebSphere Application Server for ZOS development team in Poughkeepsie, New York. In this video series, we'll introduce you to WebSphere Application Server. This is the first part of the series, and it's titled ATSWAS101, The Essentials. WebSphere Application Server has many elements that are common across all IBM platforms, so that's what we'll focus on initially. But near the end of this series, we'll start to explore some of the things that make WAS on ZOS different. That will set the stage for further videos in this series that will explore those ZOS-only features more closely. Application Server is 2/3 of the WebSphere Application Server name. So what exactly is an application server? That's what we'll explore in this first section. Let's go back in time, way back in time, to the very early days of computers and computer programming. Back then, programmers began each project with almost no prepackaged software to work with. They started each project with a clean sheet of paper, and they started writing all new code. Whatever they needed for their project, they had to write themselves. The project they were setting out to complete may have been related to a business function, for example, payroll processing or inventory management. But before they could get to the business logic, they had to go through a fair amount of effort to code up lower-level routines. At some point early on, the developers realized they had an opportunity to reuse code for frequently accessed routines, so the subroutine was invented. The key to effective reuse of subroutine code was a good understanding of what the subroutine expected as input parameters and what could be expected in return. It was discovered early on that good documentation for the input and output requirements for a subroutine promoted its reuse. That was the beginning of documented programming interfaces. WebSphere Application Server is all about well-documented programming interfaces. In 1968, IBM released a product called Customer Information Control System, or CICS for short. Many see CICS as one of the very earliest examples of an application server. What made the CICS region different was that it contained a set of program subroutine functions built in. These included communications, security, data access, and transaction services for use by programs that ran in CICS. What CICS provided was a very organized and well-documented set of interfaces to the common functions supplied with CICS. Program developers no longer needed to reinvent the same code time and again. CICS provided it, and developers didn't need to guess at what the code expected or what it returned, because those interfaces were clearly documented. IBM supplied and supported the common service infrastructure and provided documented interfaces to those functions. This allowed the business developers to focus on the core business issues. CICS became one of the most popular and powerful application servers in the marketplace. And 40 or more years later, it is still going strong. WebSphere Application Server came along well after CICS. WAS has many conceptual elements in common with CICS and a few key differences. To illustrate this, we'll go back to the picture of CICS we showed earlier. The general concept of common, accessible, and documented functional services is the same between CICS and WAS. The documented interfaces to those services is also provided with WAS, but here's a very key point. Those interfaces are based on industry-accepted open standards. Support of open standards is the core mission of WebSphere Application Server. In WAS, the programs are written in Java. CICS supports Java too, along with other non-Java programming languages. WAS supports only Java programs. Therefore, as you see, CICS and WAS are both application servers and have many concepts shared between them. The key with WAS is its exclusive focus on open standards, and Java is the only programming language supported. We're glossing over many of the details of CICS and WAS at this point naturally. We're focusing on the high-level conceptual framework. That's important because when the details start flowing, you'll need a conceptual framework to better understand the context of the details. As we prepare to leave this chart, we leave you with some very high-level concept messages. An application server is a functional runtime that provides common services so business developers may focus on the business. The key is the existence of well-documented application programming interfaces, or APIs for short. Without that documentation, the business developers would have to guess at things. But with good documentation, the developers are able to make good use of the application server platform. WebSphere Application Server is all about the support of open standards and the Java programming language. It's very important to keep in mind that WebSphere Application Server is available for a wide variety of platforms. There are some very important points we will cover based on this. We'll start with the hardware platforms and the operating systems on which WAS runs. These are the IBM platforms. WAS will run on other hardware platforms that run the Windows or Linux operating system. Over that picture of the hardware and OS platforms, we place WebSphere Application Server. Then we draw a horizontal line just under the Documented Set of Interfaces box. That represents the dividing line between the open standards that are supported above the line and the vendor implementation of those standards below the line. To the applications that operate above the open standard specification line, WAS is WAS. That means to the application there is no difference in WAS across platforms. That, by the way, is why application portability from WAS on Windows up to WAS on ZOS is possible. The application stays the same and the open standard specification support stays the same. The implementation below the line differs. The open standards are really just specifications of what function is to be implemented and what the interfaces should look like. What the standards do not say is how a vendor is to implement those standards. This is where IBM competes with other vendors of Java EE application servers. IBM implements the standards in a way that takes specific advantage of the different IBM platforms, and IBM invests heavily in code development and testing to ensure a quality deliverable. So WAS ZOS, for example, implements all the standards required, but under the specification line, IBM has implemented the function in a way that exploits the ZOS platform. In our later video section on WAS ZOS, we'll drill into what those elements of exploitation are. We've mentioned open standards several times already. What are these open standards? Let's do a quick review. First, what we're about to show you comes straight from the Product Information Center. The URL for the WebSphere Application Server Info Center is shown on the chart. Second, the Info Center article can be found by doing a search on the string r/specs as shown on the chart. What that provides is a very nice reference page for all the open standards supported, with links to other articles offering more detailed information. It's worth noting at this point that you do not need to understand or even be aware of all these standards. The important thing is knowing this Info Center article exists. You may well be asked by a developer if the version of WAS you have supports some level of a standard specification they are interested in. This page will give you that information. This is a video capture of us scrolling down through the specifications listed on this Info Center page. We offer this simply to give you a sense of the variety of open standards supported by WAS and the look and feel of this page.